We are going to discuss what is lattices, what is Miller integers, and what is crystal. Crystal is a solid whose atoms are arranged in a highly ordered repeating pattern. The lattice is an infinite array of points and each points will have identical surrounding. The lattice are classified into linear lattice, plane lattice, space lattice. The linear lattice is a one-dimensional, plane lattice is a two-dimensional, space lattice is a three-dimensional. Next, what is lattice plane? The lattice plane is a plane which passes through any three points which are not in a straight line. A set of parallel lattice planes is characterized by its Miller integers. Next, we see the Miller integers. The Miller integers are used to specify directions and planes. The number of integers will match with the dimensions of the lattice or the crystal. For example, in one-dimensional crystal there will be a one index, and two-dimensional crystal there will be a two integers. Three-dimensional there will be a three integers. Here we are using the symbols. The symbols are HK and L. So the notations, the square bracket HKL represents a specific direction in the crystal, and second symbol HKL represents a family of directions, and the brackets of HKL represents a specific plane, and this curly brackets HKL represents a family of planes. And the negative numbers or directions are denoted with a bar on the top of the number. Here a vector r passing from the origin to a lattice point can be written as r is equal to r1a plus r2b plus r3c, where abc are basic vectors and Miller integers are r1, r2 and r3. Next we will see the how to find the Miller integers of a plane. There are three steps to find the Miller integers of a plane. The first step, identify the plane intercepts on the x, y and z axis. The second step, take the reciprocal of each quantity. And third step, take the reciprocals of the fractional intercepts. Each plane here is constructed by the connecting at least three different lattice points together because the periodicity of the lattice. Here there will be a family of planes parallel passing through every lattice point. If a point does not intercept on axis, the intercept could be a infinity, and taking the reciprocal value is 0. If the reciprocal of the intercept is a fractional number, now multiply each of the HKL values by the least common denominator to get the integers. Let's see, for example, Miller integers for the plane. The first example, here the plane is intercept the x-axis is a 1, y-axis is a 1, z-axis is a 1. Next, taking the reciprocal and clear the fractional number. So we get this 1, 1, 1. So the first example, the Miller integers of this plane 1, 1, 1. The second example, the intercept the x-axis is a 1 and the y-axis is a infinity, z-axis is a 1. Taking the reciprocal and clear the fractional, so we get this 1, 0, 1. And a third example, here the intercept the axis is a x-axis is a 1, y-axis is a infinity and z-axis is a 1 by 2. Taking the reciprocal and clear the fractional, we get this 1, 0, 2. So in this example, the Miller integers is 1, 0, 2. And the fourth example, so in this plane, the intercept axis, x-axis is a -1, y-axis is a value infinity, and z-axis is a 1. And taking the reciprocal and clear the fractional, we get this 1, 0, 1, -1, 0, 2. So in this plane, the Miller integers bar 1, 0, 2. So next example, cubic. Consider the cubic plane. The first example, the intercept's length is a infinity, infinity. And next second, taking the reciprocal, we get this 1, 0, 0. So in this plane, the Miller index is 1, 0, 0. Second example, the intercept's length is a infinity and taking the reciprocal, and we get this Miller index is 110. And third example, the intercept length is AAA, and taking the reciprocal, and we get this Miller index of for this plane 111. So next we have to find the Miller indices for the plane shown in the figure. Here x-axis, intercept the x-axis is a 3a, and y-axis the length is 2a, z-axis is a 2c. And the plane intercepts the axis at 3a, 2b and 2c. So taking the reciprocals of these numbers, we get this 1 by 3, 1 by 2 and 1 by 2. And using the least common divisor, we get the 6, 2, 3, 3, 3. Hence, so in this problem, the Miller indices of these planes are 2, 3, 3. Here the numbers is represent the distance from the origin in terms of lattice parameters. For example, the cubic crystal, the Miller indices represent the direction vector is perpendicular to the plane with the integer components. Here also the silicon wafer are classified by the orientation of the Wallace crystal plane with the relation to the surface plane of the wafer itself. For example, the plane of the wafer corresponds to a corresponding 100 crystal plane. The plane of a 111 wafer is corresponding to the 111 plane. So this is silicon wafer 100 n type, 100 p type, 111 n type, 111 p type. Thank you.